It means when I calculate the eigenvector of this data, one vector will point in this direction, symmetric. That's why these axes are called principal axes for the data. And the other should be maybe, if you make it orthogonal, you can make it orthogonal, should be like this. Yeah. So this data is symmetric with respect to this axis. And why that's important? Because sometimes you transform your data, you can squeeze your data, whatever. But even if you do that, these vectors, they don't change. At most, what these vectors do is to contract or expand, but they will not rotate nothing. So, in other words, it's always important to know the axis of symmetry of your data. Okay? And that can be useful. But not okay. Why is not okay? No, negative 16 was is outside the problem. I was telling you that you can calculate determinants, but the determinant here you don't have to calculate. I was just showing an example. This minus 16 is not part of the exercise. The result of these problems are these. A, 2 minus 1, and these three vectors. These three vectors mark the axis with respect to which my data is symmetric. Symmetric means my data distribute around those axes. It distribute around those axes. And if my data distribute around some axis, that axis has some meaning in my research. It means that that direction for my data has some special meaning. It's an invariant for something, which for mathematically it's invariable. In your research could be probably a little bit, but could be, for example, in the case of airlines, for example, price demand, it could give you the axis with respect to which the relation price demand is symmetric. And that gives you a clue about how the system is behaving. Because then you just have to concentrate your attention in that direction for the data, for example. Well, in some cases, you can find eigenvalues. In other cases, probably not. But where you can find eigenvectors, but where you can find them, those directions with respect to which the data is symmetric are important. The data that we have collected is on the right side, or it's not on the right. It's pointing towards the right direction. No, it's not right or wrong, because if the data is wrong, you can still find an eigenvector pointing in the wrong direction, because your data in advance is wrong. So it will not tell you whether your data is wrong or bad. It will help you to calculate some principal axis, the axis with respect to which the data is symmetric. And those axes are fixed. No matter you do whatever, you squeeze, you transform, those axes are fixed, and they have some special meaning in your research. Because then I will be able to focus on, okay, I have this axis, so I know that all my data is concentrated around this axis. It's like when you have a normal distribution. You have a normal distribution like this, no? The expectation value here is 0. But what about if my normal distribution has an expectation value 20 here? Is it important to know this axis for you? Is it important? Of course it's important. It's telling you the expectation value of that data. So it's telling you this data is centered in this number. And when the data is centered in one number, you have to pay attention to that place. Huh?
And then after, of course, the data will spread. The other is the standard deviation, no? The standard deviation, which tell you. In the same way, no matter how the data distribute, the normal, non-normal, you can always identify the axis of symmetry of the data. And those axes of symmetry give you could give you, for example, in this case, like this case, could give you some expectation values of your data. It can help you to understand that your data is symmetric with respect to, to that axis. And then you can just, okay, I will focus in this direction. My data is pointing in this direction. My data is distributing around, I don't know how wide it's distributed, but it's around this axis. And this axis then is special. Why is it special? Then you have to think why the axis is special. Special because what? This direction, what does it mean, this direction? Maybe that direction marks some, I don't know, rate of settings or rate of expenses or whatever. It depends on your set. I cannot tell you a specific example because it depends on what you are doing. Or it can mark you a special velocity in the case of position time, or some acceleration, particularly the velocity time. In the case of business, some special rates of selling, average rates of selling, average things. So I mean, it's important to know. I mean, it's important to know the center of your data, no? It's always important. Knowing your data is centered around something, no? Then that's quite important always when you're analyzing data. Some people don't pay attention to those things. Of course, some people never do it. Some people never do these things. And I see your smile. It's like your smile is like I don't understand anything. Or
It's like if you like refuse to accept the new things, right? Then no matter how long you take the class, it still works. So that's the reason why
I didn't understand what it's okay. I didn't understand what you said. But anyway, the issue is it's like that. Okay. Then of course, as I told you, you can decide in your research if you use these things or not. But it's my obligation to share with you these things. Now let's go back. Uh-huh.